Deoxygenation happens when oxygen in water is used up faster than it is replenished. Main causes for this are excess nutrients and rising temperatures. As a result of global warming, oxygen levels have declined by 2% in the open ocean since the 1950s.
The build-up of greenhouse gases caused by anthropogenic activity is decreasing oxygen solubility in the ocean. In conjunction, warming water causes an increase in metabolic rates, thus accelerating oxygen consumption. Ocean stratification is influenced directly by global warming, and indirectly through ice melt and precipitation. Changes in stratification of ocean causes alterations to the oceanic currents and ventilation to be decreased, meaning less oxygen can enter the ocean. This is thought to account for over 85% of the oxygen loss observed.
All hierarchical levels are affected by these changes, from genes to whole ecosystems. In fish, reproduction is reduced because low oxygen levels impact growth, and as a result, less energy is spent on reproduction. In addition, they are more susceptible to disease due to altered immune response, which in turn reduces growth. A drop in population numbers has a detrimental impact on fisheries and marine ecosystems. When fish have to escape low hypoxic depths, they are exposed to predators due to the light. Although not all fish are negatively impacted, as those capable of entering hypoxic zones for short periods of time are able to prey on organisms in these regions and then return to the higher depth. Now let's look a bit deeper into the anoxia at a chemical level. Firstly, toxic chemicals such as hydrogen sulfide and methane are produced in anoxic conditions, which are poisonous to aerobic organisms, which require oxygen to survive. In addition, cadmium, copper, and zinc form sulfide precipitates, and this results in less nutrients for phytoplankton, which are the foundation of the food web in the ocean, and so their reduction would have detrimental impact on life in the ocean as a whole.
All the fish died.
Nitrogen oxide is also produced at low oxygen levels, causing less nitrogen to be bioavailable, which is in turn bad for ocean productivity. What can we do to reverse this scenario? To mitigate the effects of hypoxia in marine ecosystems, we should limit further declines in oxygen by reducing the two main drivers: greenhouse gas emissions and nutrient input from sewage and excess fertilisers. Create marine protected areas and no catch zones while improving fishing to reduce additional stress. Globally work together to measure and predict the extent of destruction that oxygen loss will cause our oceans in different global warming scenarios. This means utilising new technologies, keeping these technologies cheap and accessible for all, monitoring results and collecting data and sharing it in global databases, making prediction models to inform fishery management and policymakers. Nevertheless, there are still many uncertainties about the ultimate effects of deoxygenation. We know it will certainly affect economies and food security as millions of people remain dependent on ecosystem services provided by fisheries, coral reefs and more. So, to maintain our marine ecosystems and keep all these wonderful creatures in our oceans, stop the rising tide of deoxygenation.